You might be familiar with some acronyms ending in OS representing the words operating system, such as with Microsoft DOS or Aperture's Gladys. One example that you might not be familiar with is ROS, the robot operating system. ROS is not an operating system in the traditional sense, it's really more of a framework to make different parts of a robot talk to each other a little bit more easily. While I haven't used ROS personally, the Lunabotics team that I'm a part of through my university does use ROS to control all of our mining rovers. For that reason, I thought it'd probably be a pretty good idea to understand how ROS works under the hood. My friend Nick and I both decided to independently try and learn ROS over the winter break so that we could be a better help for the software integration efforts during the spring. Initially, my goal was to simply get a motor turning. However, I decided to try and do something a little bit more complex so that I could get a little bit more under the hood of ROS. I decided to make yet another Gamepad controlled rover. I'm Caden here with Kepler Electronics, and let's get started. My friend Nick originally convinced me to learn ROS the last day of finals week, so there was no chance of any parts I ordered arriving before I was supposed to fly out in a week and a half. However, this is not my first rodeo when it comes to little robot projects, so thankfully I already had a bunch of parts. There were three main parts to this project: Raspberry Pi, which I already had from the last time I built a rover, a tracked chassis, which I had from a different rover project that I never made a video on, and some sort of a motor drive. The motor driver that I chose was the Adafruit motor hat, just because it could natively plug into a Raspberry Pi, and in theory I wouldn't have to do a ton of coding for it. Supposedly there were ROS packages for this that already would work, but in order to better understand the inner workings of ROS, I decided to design my own. In theory, it shouldn't be that big of a deal, it should only be a couple lines of code, but we would soon see. The first hurdle was getting ROS installed. I originally planned on installing ROS1 Noetic, since my friend John said that ROS1 would be a little bit easier to learn than ROS2. However, ROS1 will be fully deprecated at the end of 2025, so anything I learned I would have to relearn in ROS2 anyways after just a couple short years. I figured I might as well dive in and swim in the proverbial deep end with all of the turtles. Oh yeah, speaking of turtles, every ROS distro is named after a different turtle. The current long-term support distro is Humble Hawksbill. Look, that's a Hawksbill right back there. Look at that guy go. Getting over the installation hurdle ate up several days of the project. ROS2 Humble will only install on Ubuntu 22.04, and there were 4 options for this: Standard Ubuntu distribution, Ubuntu's Mate distribution, Ubiquity Robotics ROS preloaded distribution, and Ubuntu Server. The first 3 of those options had a GUI, so they had windows and mice and all that stuff. However, the problem is they were super heavy and took a lot of hardware resources, so even moving the mouse took like a couple seconds to respond sometimes. Ubuntu Server, on the other hand, only terminal, so I hope you feel like being a hacker man, because that was the only option for me. There was just one small hurdle with Ubuntu Server. Ubuntu Server doesn't natively come with the packages required to connect to Wi-Fi. If you want to do that, you have to connect it to Ethernet, then install those packages, and then you can connect it to Wi-Fi. I don't know why those aren't included as standard, but it's a hilarious oversight, and I really hope you have access to an Ethernet port if you're planning on using Ubuntu Server on your Raspberry Pi for anything that requires Wi-Fi. However, after I got Wi-Fi working, I was ready to go. I could attach my motor hat and run through Adafruit's tutorials to get the motor hat working, and everything worked. I didn't break anything when I tried to solder it. So the next step was to install ROS2, following the instructions in the documentation. This might be a good time to explain exactly what makes ROS so special. The gist of ROS is that you have a set of nodes, each of which can publish or subscribe to a variety of topics. These topics carry messages to and from these nodes about different things on your robot. Maybe it's sensor data or motor control or something of that sort. Here's a handy GIF from the ROS documentation that goes over exactly how this message flow happens. These nodes can be built in either C++ or Python, and I chose Python because I've been meaning to brush up on my snake handling skills. These days, most of my coding is in Lua for game development or MATLAB for my coursework, so this was a really great excuse to get more comfortable. I followed the tutorial and the documentation to get the simple hello world node going, after which I unceremoniously mixed in the 4 lines to make the motor hat work. Much like eating cereal with Mountain Dew, it will get you up in the morning, but it's not particularly pretty. I then moved on from this and did the publisher subscriber tutorial. This tutorial showed how to have one node publish messages on a topic and have another node subscribe to those messages on a topic. I then modified the subscriber node to take this topic input and control the motors based on this. And this worked really well, except for the motors not stopping when I stopped the node. However, any system that would be controlling the motors, such as the Gamepad, wouldn't have this issue because it would be sending stop commands with the data stream. There are a few ROS2 Gamepad packages, but the one I ended up going with was Joy. This package comes from the ROS package repo as a pre-compiled binary. This could be relatively easily installed, though it did take a little bit of figuring out how to make it work, and I ended up finding this forum post that talked about how to do it. The gist of my issue was that you have to source your ROS packages so that ROS understands where they are. However, since this was installed in a different method from the built packages, I had to source that as well. And after I did that, I could see the massive amount of data that this node was collecting from the Gamepad. The Joy node outputs a special message which is comprised of several smaller data types, much like a calzone. This includes an array of floats which represent all of your analog values such as triggers and joysticks. Well, there's also an array of ints which represents all of your button presses. For our use case, the joystick values are already mapped from -1 to +1, which is great because that's the value type that the motor hat is expecting, so we wouldn't need to do any extra work. This meant that it was simply a game of updating the topic that the listener node was listening to and adding a little bit of code to merge everything together. At this point, the rover could drive back and forth, but was tethered to the monitor and keyboard, which is not exactly ideal for a mobile rover. This is where the Launchfile comes in. This is a special file that will launch multiple nodes at once without you having to really do that much, and it can be written in Python, XML, or YAML. I chose Python just to keep the snake theme consistent. This proved to be one of the most frustrating parts of the whole project. While the Joy node would run perfectly fine every time, my custom node would not, and would always error out with code 2. It seemed like this was an issue with the arguments being presented. However, all of the answers I could find were for ROS1, and as stated earlier, I was using ROS2. I ended up stumbling upon a solution to this, which is that if you just get rid of the namespace lines and the name lines in your launch file, everything just works fine. I'm not entirely sure why this works, but it does, so I figured I'd put it in this video for whoever ends up using this as a reference in the future. After this, I took all the startup commands and threw them into the bash startup script, which meant that I could start it up, take it out to the kitchen floor, and drive it around. I was having a bunch of Bluetooth connectivity issues, so I had to stay tethered. However, it did work. It was kind of like walking a dog, except with fewer legs and more treads. Oh look, that one just came off. That's great. In order to wrap up this video, I thought it might be worth talking about ROS. The primary question I had going into this was, is it worth learning ROS? A lot of people use ROS. It's very popular in complicated robotics projects, and it always seemed very intimidating. But what I can say is that it's not quite as bad as you would expect it to be. It was frustrating, and a lot of that comes down to both my inexperience using it and also the apparent lack of documentation in some areas, but it's possible that I just couldn't find it. So if you know of any cool places that have good ROS documentation, let me know. I'd love to see them. There's definitely a threshold below which ROS is not worth that time investment. I have a hunch this hinges on whether or not you need autonomy or not. If you want to use LiDAR or image recognition or any of that stuff, then ROS is probably worth looking into. It might save you some time. But if you just want to see some motors turn and maybe drive a thing around with a controller, then it's probably not worth it, and you'd be better off just using an Arduino or a Raspberry Pi standard scripting or any of that stuff. If that's all you want, I may have a couple YouTube videos to show you. With the way this is programmed, I should in theory be able to take my LiDAR setup that I already have, take my path planning algorithm, and shove it all together. In practice, who knows? I've heard it's supposed to be pretty simple to just take a bunch of pre-built ROS stuff, But I also know that there's a full semester course taught on this at my university, so I don't know, we'll find out. Anyways, I really hope this video was informative. If you want to try this project for yourself, I really encourage going in blind because it was a pretty fun puzzle to solve, even if it was frustrating at times. I do have a more thorough write-up on my website, which has links to a lot of the places that solved my problems, because I tried to keep track of all of those. So, if you end up getting stuck somewhere along the way, either ask in the comments of this video, reference the website, or, just do what I did and keep Googling. With all that said, thank you so much for watching. I really hope you enjoyed this video, and I had a lot of fun making it. So, thank you all for watching, and I'll see you next time. Take care. Bye-bye.